Welcome everyone. Now it's time to implement the game of life class, and as you can see I have copied over this template from here to here. And so let us see our first question. We have to implement the fill grid with life cells method, which is here. We have to implement this and it is going to fill the grid. Here is the grid, named grid only. It is going to fill the grid with life cells as told by the get life cells method. So first what we are going to do is to declare our own an array of integers called life cells, maybe a better name, life cells, and that will be to get initial life cell method. So this it will call the get initial life cell method. It is going to return the array, and as I told you, it would be like this. It would have even numbers and we have to determine which grid cell is the get life cell. So now we are going to iterate over the life cell array to figure out which cells of the grid we have to make alive. So for initialize I to 0 till I is less than live cells dot length, notice no brackets, and I plus equals 2. And now we are going to make some particular grid cells true. What are going to be those grid cells? They are live cells ith and live cells I plus 1, and it will work. See here, when I is equal to 0, then live cell 0, whatever is in live cell 0, that happens to be 3, and live cell I plus 1, that is 1, 4. So grid 3, 4 will be true. Grid 3, 4 will be true, and that's exactly what we wanted, and this function is done. Moving on to the next one. Now we are implementing the get live cells around method, whose job is to count the number of live cells around a particular given cell, and we will implement it here. So we will initialize count variable to 0. Now if this grid cell a minus 1 b minus 1, if that happens to be true, then of course this whole condition will elaborate to 2. In that case we are going to do count plus plus, and for the 8 particular neighbors we have to keep doing this thing 8 times for different variables, which I am just going to change. So now we are going to change the cell. Look at this. If this is the particular cell, A and B are the cell columns. A minus 1, B minus 1 will be this. A minus 1 B, A minus 1 B plus 1. Here we have got our first A minus 1 B minus 1, A minus 1 B, and B plus 1. Next we have A B minus 1 and A B plus 1. A B minus 1 and B plus 1. Next we have A plus 1, A plus 1 B minus 1, A plus 1 B, A plus 1 B plus 1. So now this all is going to be plus and minus 1 plus 1 and the B itself, and this, all these conditions are enough to ensure that we count everything. That's just for formatting reasons I put the space here, nothing special. And we have implemented our get live cells around method, only just the return statement remains. So return the count. Moving on to the next one, the next gen method. So we are going to implement the next gen method. Its job is to update the grid and reflect the next generation, and it is going to determine the fate of each of the cell, the next gen cells, with these set of rules. And now let us look how to implement that. So first we are going to make a new grid, boolean next grid is equal to new boolean, the length, the constant which we have declared here, and its value would have been initialized in the constructor later whenever the constructor is called upon. And length, it's a square grid, I told you. And next, we are going to iterate over each and every column of this next grid, and so we need a for loop. And remember, in this whole game of life, we will be doing nothing to the border cells, and get assured that neither get live cells, that fill grid with live cells is going to be called with some border cells. And so we are going to just leave the borders because they don't have 8 adjacent cells, so we can't account for them. They are very special rules, complicated rules, which we are not going to deal with them here anyway. So int r, this will be the row, is equal to 1 till r is less than length length minus 1. Well, actually you can do this also, grid dot length minus 1, but every time this loop is going to run, the computer will calculate what is the length of the grid. So this is not efficient. Instead of, we will first calculate the length of the grid and then use that value again and again. This is more efficient to use length here because that calculation of what is the length of the grid will go again and again here in this constructor, and we don't need to do again and again. It will finalize this length component, and so r is less than length minus 1, so that it doesn't even touches the border cells, and r++. Next is the for the column. Nearly simple, near exactly the same, but just the change in the variables. Minus 1 C++. Now we are going to first initialize the next grid of R and C to be equal to false. We have to do it, either you do it in a separately nested for loops and then we focus on the main logic behind finding the dead or alive cell, or you can do it like this also inside both the work of first initializing the next grid loop and the work of finding which cells are alive in the same nested loop. So we'll get the count. So initialize count is equal to get live cells around of R and C. Remember, this live cell around will only access the main grid, which is right up there, the private boolean instance variable. And once we have the count, if count equals, that means equals 2, or count equals 3. That was the rule. If count equals 2 or count equals 3, the next grid cell of that R and C will become true. And it is as simple as that. If the count is 4, 5, 6, then it has to remain false. If the count is 0 or 1, it has to remain false. And when this iteration will occur over and over again for numerous time, then our next gen grid will be there, and then we'll make the grid be equal to the next grid, and we are done for the game of life class. Thank you.